Si k es 0, thank you. Si k es 0, entonces 0 square minus 4, ¿no? This is for k equals 0. Plus, and the rest is k 1, 2, 3, 4, 5, 6, 7, 14. But no. You don't want to expand totally. No. I copy like that. Sigma k1 to 14 of k squared minus 4. Okay? It is obvious that this is negative 4. And this summation we can separate using the property and two summation. One summation like that, and another summation like that. Okay. And now we are ready to apply this formula, because this formula is starting 1 to the n. Okay, n represents any natural number, no? In this case, 14. So this is negative 4 plus something. Look at the formula. The formula say m. Guys, this formula is super useful in calculus 1. M, in our case, is 14, no? N is 14, is the upper limit. M plus 1 is 15. And 2n plus 1 is 2 times 14, is 28, plus 1 is 29. So basically, this summation is equivalent to, say, 14 times 15 times 29 divided by 6. Do you see that? Everyone saw that? We're going from, it's minus now, minus. And you apply the entonces you apply the property when it's a constant, it's just multiplication. It's multiplication 14 times 4. Well, the rest is arithmetic. Negative 4. Okay, what does the E stand for? E. What E? What E you talking about? E. Activate the microphone and ask me direct. The letter next to the 14. The letter next to the 14.
So you know how you have it says 14, then it has that character thing, and then it has K equals 0. Symbol. What kind of symbol is it?
What kind of symbol it is? 0?
Yeah.
This symbol you say?
No, yeah, the symbol. So you see how you have N over the E, I guess, and then you have K equals 1. Then K
You say,
squared.
you ask me in this formula? In this formula?
Yes.
In this formula. This is M.
Okay.
M plus 1. 2M plus 1. Divided by 6.
The one next to it. So like, you know how it says equals?
This one? This line?
No, the other one.
The other
next
one?
to 14. Yes, that one.
Well, that 14 you say?
Yeah, so you know how
well,
it's
this is
above?
sigma. This is summation from k equal 1 to 14 of k squared.
Okay. Thank you.
But well, I never understand what is your question, no? But it's okay.
I just wanted to know what that stood for. Like, where did you get that part?
Okay.
Just the formula.
Oh, no, the formula. Okay, the rest is just take the calculator. This is negative 4. This is 1015. And this is 64. And now you 68 negative subtraction 955. That's the final answer. Okay. The new thing that bring me this example is number 1, using that formula to use that formula. Number 2, how you manipulate the summation can start knowing 1, because any formula start in 1. Suppose that the formula start in 0. To say, my recommendation is you expand, you break it down, the 0 part, and we now start in 1. See, the summation starting another number. Let's see example now. Entonces, clear the example 1. Let's move on to example 2. In example 2, I need to compute sigma summation from k equal 10 to 60. Okay, we can expand it, we can, pero entonces es too long because it's 10, 11, 12 to 60. No, too long. Entonces, well, I separate, no. Sí, I separate. So I'm using the property because I know formulas when the k start in 1. Pero I don't know formula when the k start in 10 or any arbitrary number. Pero no, I separate, for example, I know okay, we can compute using the formulas from 1 to 60 of 2k. But you need to discount another guy que do not participate in the summation, que is from k equal 1. It's important that always the lower bound or limit is 1 to 9 to 2k. Because we have, okay, this summation computed from 1, 2, 3, 4, to 9. Okay, entonces, this summation, que es the thing I want, you obtain with the entire summation, que is this, minus subtraction, that part. Now ready to apply our famous formula to time. Well, first of all, why no? I understand that this 2 is a constant, so I factor out outside the summation symbol. Now I computed separate this and this. Okay? Little by little we processing the information. Okay. Now I know that formula. Summation from k equal 1 to m. Okay, this is m, sorry. Is equal n plus 1 divided by 2. This is the formula. But in our specific case, this is 2. That part is 60 multiplication 61 divided by 2. Big bracket. Minus, this is 9 multiplication by 10 because it's n plus 1 and 1 more divided by 2. Es obvio que the 2 is cancelled. Basically 60 times 61 is, well, it's 2 times, I put in the calculator this entirely. This is 1830 minus 45. It's 45, look. Because it's 10 divided by 2 is 5, 5 times 45. And now subtraction, multiplication by 2, the answer is 3,507. Do you understand the procedure? Do you understand the idea? Okay, my formulas is super fantastic way to compute the summation. However, what is the only disadvantage? One of the only disadvantage is que start in 1. See, my summation do not start in 1. In this case, start in 10. So I separate. Okay, I computed the complete summation from 1 to 60. And you subtracting the part that you don't want, que is from 1 to 9, 1 less than the lower limit, no? Do you understand or no? Tell me. Okay, let's do one similar. Example 3. Example 3. In example 3, we have summation from k equal 4 to 24 of the k cubic. This is similar, but you need to remember the summation, the formula associated with that problem is from 1 to m k cubic is very, very similar to remember because it's similar to the when the k is 1. When the k is 1, look, when the k is 1, this part do not exist. This is the formula. We are familiar. We're working with this. However, it's cubic. The formula is the same except it's a square. Unbelievable. We can prove that, pero no now. Well, entonces ahí separé this summation into summation. And both summation is subtraction starting 1. Because allow me to apply that formula 2 times. Okay, entonces this is to 24, que es the upper of k cubic. And this is to 3, because k cubic again, no? Because remember I need from 4 to 24, so you exclude 1, 2, and 3. Is that part. Okay, so we're using the formula 2 times. Is basically 24 multiplication by 25 divided by 2 and a square minus, well, this is 3 times 4 divided by 2 is square. The rest is calculator. This is 300 square and minus 6 square. This is 6 is 12 divided by 2. This is 12 multiplication by 25, 300 square minus 6 square is equal, put on the calculator, definitely 89,964 is the answer. One more detail. I bring another example. Do you understand the idea, guys? It's similar. It's a similar, different formula, but it's similar. Are you familiar, for example, with this idea? Sigma from k equal 1 to 5 of the constant, que es 80. Oh, so I am super familiar when this is 8, when this is constant, your multiplication, this and this, is 400, no? Because actually, the thing we are doing is 80 plus 80 plus 80 plus 80, so 5 times, no? Plus 80, no? It's obvious that the multiplication 80 times 5. However, the problem I propose you now is sigma from K3, K3 to 5 of 80. Entonces the student, wow. Entonces, well, I don't understand very well because this is for K1, look. This is for K2, remember K is the index variable, give me the sequence of the summation symbol, no? This is 3, this is 4, and this is 5. Okay, so actually, the thing we need is only this. Bang, bang, and bang. So from K3 to 5. Okay, actually it's 80 plus 80 plus 80 is 240. But what's the formula then? I don't understand very well. The formula in this case was easy. It was 80 times 5. Now you multiply this number times this number. But in this case, you multiply this number, is the number inside the summation, no? But how many times? 3 times. Why 3 times? Because it's use subtraction 5 minus 3, but 5 minus 3 is 2, plus 1 is exactly the number that we need, que es 1, 2, 3, ¿no? Entonces, basically, entonces, what is the formula? Well, the formula is the number 80, and you subtracting the upper minus lower plus 1. Bueno, professor, entonces, what is the reason? Que here I don't know addition extra 1. Because in this case it's 80, upper is 5, lower is 1, plus 1. Oh, entonces now it's cancel out. This one is just 5 times 80. Okay. Entonces, when the lower bound or limit is no 1, you subtract the upper minus lower y addition 1 extra 1. What is the reason that we need to? Because in between 3 and 5, count both endpoints, we have 3 elements. 3, 4, and 5, right? Make sense or no? Make sense or no? No? For example, one similar and number 4, no? Actually, what is the problem number 4? This is the problem number 4. And this is a example number 5, it's similar. A summation from K20 to 50 of 80 again. Or any constant in general. This situation that we are talking about here is when you have constant. See, we have variable, you have K, no, we're using the formula. Entonces, basically, remember, it's 80 multiplication by subtraction, 50 minus 20 plus 1. End the story. This is 30 plus 1, 31. 80 times 31. The answer is 2,480. That's clear or confusing? Let me see if I have another interesting example. Clear, super clear. Okay. Let me try one more on that seat. Number 6. Number 6 is summation from K equals 6 to 20 of 4K squared. Okay, in this case is not applicable the rule before, because the rule before we're using is when the number inside is just a constant. Okay, so now I'm using this idea. First of all, this 4 is a constant, I factor out. So I separate into summation. The variable inside is K squared. And the first summation starting 1, as always, to apply the formula. And this ending in 20, because it's the upper limit. And here is in 5, no? Because this part covers from 1 to 20, but I need from 6 to 20, so you're subtracting from 1 to 5. Eliminate this guy. Subtraction. Now ready to apply the formula 2 times. So it's equal 4. Remember the formula, and K squared is n plus 1, 2n plus 1 divided by 6. Entonces 20 times 21 times 2 times 20, 40 plus 1 is 41 divided by 6. Minus. In the second case, n is 5, n plus 1 is 6, and 2n plus 1 is 11, no? Because it's 2 times 5 is 10 plus 1 is 11 divided by 6. Now, the rest is just calculator 1. Okay, put in the calculator 4. This is 2,870 minus 55. Now, subtraction and multiplication by 4. The answer is 11,260. Okay, this is the way to manipulate. Okay, when it's a constant, it's a little bit special. When there's no constant, when you separate in 2. And remember the formula that we are using, always start in 1. Any question? This is no big deal. This is perfect understanding for everyone. No, normally, no, when they teach in that part, everyone understands very well this. Clear or confusing? I want to hear information. Let me check it out again, the attendance. Wow, I have a lot of students, but the students are late. Queen is okay, Jasmine is okay, Cesar is okay, Jancy is okay, Laura is okay, Lustig, wow, late. Vance, late. Frank, late. Karen, no, it's okay. Yeah, it's a joke. Karen, Betancourt, and Sean. Okay, let's move on to another topic. We're discussing now arithmetic sequence. Okay. What definition? Well, let me, before the definition, let me try to illustrate the idea with the example. Suppose this sequence 4, 6, 8, 10. And continue forever following this pattern. So the first thing you should do always is try to find the differences in between the elements. This minus this, esto. This minus this, esto. This minus this, esto. I discover que the common difference, esto, this is common difference. When the situation happens, when the sequence have a common differences, it's because it's arithmetic sequence. Okay? So basically, I suppose that the first guy is a sub 1. A sub 1 in our example is 4. A sub 2 is 6, but it's also a sub 1 plus d. And so on. A sub 3 is equal a sub 2 plus d. Entonces one formula. Remember, we have two formulas to identification the sequence. One formula is called recursive formula. Recursive formula. I don't know why when the teacher explain that part, they are a mystic. It's not clear, it's confusing. No, it's super easy. Look, recursive formula is a formula that is not definitely the entire formula for the sequence. It's one formula que is not the best, pero es something que stay the relationship between, for example, any element and your previous, not necessarily the first previous or the second previous. In this case, the first previous, a sub m minus 1 plus d. And you see clear here, look, and you see clear here, a sub 3, when the n is 3, this is a sub n minus 1 que es 2 plus d. So you can see clear the relationship between the element and the sequence is, well, you take, in order to find the next, you take the previous plus the common difference. But some people say, no, but I don't like that formula. I don't like. Okay, no problem. However, another way to express the same idea is, look, this is A1. This is A2, que es A1 plus D. A3 is A1 plus 2D, and so on. Because you use substitution, for example, here, boom, you adding D plus D to D. So in general, the explicit formula, or the famous formula for the A sub m, so the book called explicit formula for the sequence, or just A sub n, it's the same, is A1 plus n minus 1d. Wow, in my opinion, this is the most important formula. So always the explicit formula is the most important formula. Let's see one elementary example. Elementary. Suppose, example 1. Suppose we have that sequence 2, 6, 10, 14, 18, and you put that indicate that this continue forever as infinity. However, it continue with the same pattern. Entonces I investigate the common difference. One is 4, S4, S4, and S4. Okay, the S4 in our specific example. Therefore, if you want to find the formula for this sequence, the A sub n, well, I'm using that formula. A sub n is equal, A sub n is equal, A1. Who is A1? A1 is the first. This is A1, que es 2. Plus n minus 1 multiplication by d, que es df4. And that's it. That's it? No. I need to manipulate a little bit. You have apply this. N is equal to plus 4m minus 4, right? Finally, we combine like term for n minus 2. Ooh, this is a formula. This formula is valid for everything. You check it, for example, suppose n equal 1. N equal 1 here, 4 minus 2 is 2. Perfect. Checking. For n equal 1. For n equal 2. This is 2 times 4 is 8 minus 2 is 6. Good. For n equal 3 is 12 minus 2 is 10. Perfect. That's work. Any question? It's easy, eh? Okay. Let me complicate a little bit. Suppose example number 2, in which you have no clear the information. Suppose that you need to find the formula, the A sub n explicit formula for the one arithmetic sequence. I know it's arithmetic sequence, but A sub 8 is 75. And A sub 20 is 39. So you need to find what? Find A1, que is the first one, it's not given. Find D. And why not? Find the A sub n, que is the explicit formula for the sequence for any element of the sequence. Okay, let's do it. So we have in this case two numbers and two, but it's given the position. In the position n equal 8, the value of the sequence is 75, and the position 20 is 39. Wow, but what is the reason that because it's decreasing? So sometimes I predict, using my common sense, right? I predict that the common difference is negative because the sequence is decreasing, no? Okay. So I use my formula. The formula is A1 plus parenthesis n minus 1d. This is the most important formula today, or at least in this part, arithmetic sequence. Now, I apply the formula 2 times. I apply, for example, A sub A is A1 plus 7d is equal 75. Why 7? Where come from this 7? Because it's A minus 1. It's the first guy, I have no idea. And the common difference, I have no idea. And likewise, in 20 is A1 plus 19d equal 39. In this moment, we have two equations, 1 and 2, and 2 all know, case A1 and D. And we are expert. Solving system of equations. For example, one idea is subtraction, equation 1 minus equation 2, because this is ready for elimination. So this is 0. Okay, this is 0. Subtraction, this is 7 minus 19 is negative 12d. On the right hand side, we have 36 divided by minus 12 both sides, and 3 is minus 3. That is expecting, because the sequence is decreasing. It's negative sequence. Negative sequence, no, it's decreasing. It's decreasing. In order to find the A1 value, well, you're using either equation. For example, using the first one, I don't know why. The A1 is plus 7 times negative 3 is equal to 75. This is negative 21. Therefore, A1 is equal 75 plus 21, que is 96. Okay, ready to express it. Well, you found this guy done. This guy done. Now finally the expression. The expression is, well, let me write here. A sub n formula is equal 96 plus n minus 1 multiplication by negative 3, no? Therefore, a sub n is equal to 96. You apply this 3 with the property here, is minus 3m plus 3. Okay, super. Entonces, a sub n fórmula is equal 96 plus 3 is 99 minus 3m. Wow, I like that. This is my general formula que identification perfectly everything. Just in case the verification, you can plug it in a here. There's a 99 minus 24. Let me see. 99 minus 24 is 75. Super. N equal 1 here is 99 minus 3 is 96. Super. Any question, guys? Okay. Then we have another application. No question. Okay. Thank you. We have another application for the arithmetic sequence, que is the summation. So I need to find the summation. For example, is this a equal number of the example? It is 2. Example 3 now. Suppose that you need to find the sum of the any element of the arithmetic sequence. Suppose this example, 60 plus 64 plus 68 plus 72 plus that, and that is very hard because I don't know how many elements we have in this sequence, 120. And I stop here, no more. Actually, it's not totally sequence, it's a portion of the sequence that I want to find the summation. What is the formula? The formula for the summation of the one arithmetic sequence is equal m over 2 bracket a1 plus a sub n. Wow, it's easy. It's easy because the only thing you should do is you average. Look, a1 plus a sub n is the interpretation, in my opinion. You average the first and the last. So 120 plus 60 divided by 2. And multiplication by the number of the element. This is the formula. Super easy to remember, super useful when you have only applied for it. We have a arithmetic sequence. It's a no arithmetic sequence. Well, no. We cannot use it, no? The challenge is, what is the unknown? What is the thing that you don't know or you are not clear? It's m. How many elements we have in between 60 and 120? Well, this is A1, I suppose. This is A2, this is A3, and so on, no? Pero this is A sub m, que by the way, I don't know who is m. Okay, but I'm using my formula. My formula A sub m is equal to A1 plus n minus 1 d. Okay, by the way, the common difference is 4, no? D is 4. It's obvious. 64 minus 60, 68 minus 64 is 4. So we have all elements. A sub n is 120. Because it's the the element in which I want to find the index variable k, what value it is. So a1 is 60 plus a minus 1 multiplication by 4, and solve for it. Solve for m. So basically it's easy because it's 120 minus 60 divided by 4 is equal to a minus 1. This is 60 here, 60 divided by 4, 15. 15. Therefore n is 15 plus 1 is 16. Oh, I discover that 120 is located in the position 16 in our sequence. So basically, I come back to my formula for the summation. Summation sub m is equal to 16 over 2, and you adding 60 plus 120. Okay, and the story is 1,440 is the answer. Okay? Easy or complicated? I told you it's easy. Everyone follow me? Come on, I want to hear your opinion. Everyone understand very well the sequence? That is made the sequence, no? We have another sequence que we studied today, maybe. Okay, let me erase the board. I understand, okay. So I need help in the next example. Okay, it's example 4, no? A 4 or 5? I don't remember. Suppose 4, F4. Suppose 4 plus 4.5 plus 5 plus 5.5 plus plus, and the last guy is 100. Compute that. Well, first of all, I need to verification si es or is not arithmetic sequence. Okay. Bueno, it's clear que A sub 1 is 4. But the common difference is 0.5. 0.5. Remember, you're subtracting in order to find the common difference. You subtract any element minus the previous. And the common difference. See if this is a constant, and then this is the arithmetic sequence. Otherwise, no. Let's see another example that do not satisfy that condition. Entonces, the equation that we studied is valid only for this. So I need to find the element. This is n equal 1, n equal 2, n equal 3, n equal 4, and this is, I have no idea, n equal m. This is similar. You copy the formula, a sub m is equal to a1 plus n minus 1 times d. N sub n is 100 is equal to the first que 4 plus n minus 1 multiplication by 0.5, 1/2. Okay, you solving is 100 minus 4 divided by 1/2. Okay, it's equivalent to say multiplication by 2, no? Is 192. It's equal to n minus 1. Therefore, n is 193. This element is located in the position 193. Okay, finally, the formula summation for a sub m is equal n over 2, and the average is a1 plus a sub m. It's a formula, easy to remember. In our specific case, s sub 193. Okay, by the way, this is one symbolic way to write like that. Sigma from k1 to 193 of the a sub k. A sub k is this element. Okay, is equal 193 divided by 2, bracket 4 plus 100. 104 multiplication by 193 divided by 2 is 10,036. Clear or confused? Okay, super. I want to do one more. And that's it in arithmetic sequence. Example 5. Okay. Example 5 is 8 plus A1/4 mixed number plus A1/2 plus A3/4 3/4 plus 9 plus bam 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 50. Computer. So, well, I know that A1 is 8, A sub m is 50. And D, I have no idea. Well, it's obvious that D is 1/4. As you're subtracting this, maybe the sequence you can see increasing 1/4 plus 1/4 plus 1/4 plus this is the common difference is 1/4. Okay, again I need to find the n associated with the 50. I have no idea. I'm using the formula again. This is my very important formula. A sub n is 50. A sub 1 is 8. And D is 1/4. Basically 50 minus 8 divided by 1/4, que is equivalent to say multiplication by 4, is 168 is equal to n minus 1. Therefore, n is 169. So this element is located in the position 169. This is n equal 1. This is n equal 2, but this guy is 169. Now the formula summation of 169 is equal 169 divided by 2, bracket A plus 50. 58 multiplication 169 divided by 2, the answer is 4,901. Any question? No. Very good. Very good. Good student I have. Okay. We have another sequence. It's very interesting. Case geometric sequence. Well, one elementary example to understand geometric sequence is, for example, this. Suppose a sequence 2, 4, 8, 16, 32, It's obvious that we have no common difference because 4 minus 2 is 2 and 8 minus 4 is 4. Yeah, it's different. No common difference. However, we have a common ratio. And what is the definition of common ratio? Common ratio is you divide any element divided by the previous minus, no plus, sorry. Then to say instead of subtraction, no, we are doing division. 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. 32 divided by 2 is 2. And we have a common ratio R, que es 2. Common ratio. es constant. Y when the common ratio is constant, we are from the geometric sequence. Okay, this is the proof. This is the proof. You subtracting first. Si there are no common difference, entonces you divide. Entonces es geometric sequence. And the formula for the geometric sequence is, look, the recursive formula. Remember we have two formulas, recursive formula and the explicit formula. I like so much explicit. The problem is that sometimes it's impossible or very, very, very complicated to find the explicit. But in this case, no, it's easy. So basically, the first one, the any position element is equal the position in the previous multiplication by r. Or in general, is a sub n is equal to a1 multiplication by r raised to the n minus 1. Wow. N minus 1. And this is my important formula. Okay. Let me try to find one example. Yes, this example is okay. Suppose example number 1, que always is kindergarten example. Suppose we have one sequence like that, 4, 16, 64, down. And continue forever. Es obvio que A1 es 4. And the common ratio is also 4 because 16 divided by 4 is 4 division. And 64 divided by 16 is 4. I suppose that when I put this dot, it's because the next digit or the next number, is 64 times 4. Okay? Okay, entonces, what is the goal in the example 1? Well, and the goal is find the formula, that formula, the explicit formula, a sub n. Is equal 4. Is equal 4, que es a1 times 4 raised to the n minus 1, because they are a coincidence. It's a coincidence. And between the first element and the common ratio. And leave it like that? No, of course, no. I apply some algebra always. It's a 4 to the n. End the story. Because it's a 4 to the 1 power, you multiplication, remember the rule, addition the exponent, and positive 1 and negative 1 is cancelled, and stay 4 to the n power. And it's logical for the n equal 1 is 4. For n2 is 4 square, is 16, and for n equal 3 is 4 to the cubic power, is 64. Super easy. Okay, suppose one more complicated problem. Example 2, geometric sequence. We are talking about geometric sequence. We suppose we have 10, 9, 81 over 10, and 7, 29 over 100. Bam. And they want to find two things in this case. You find the explicit formula, a sub n formula. Now I need to find the a sub 9 in the position 9. Two things. This is the position 1. This is the position 2. This is the position 3, 4. But I need to find 9 and the general in any position. Ok, entonces es obvio que a sub 1 es 10. And the common ratio, I have no idea. Pero you divide. The common ratio, you divide this divided by this is 9 over 10. Suppose que you divide this divided by this is 81 over 10 divided by 9, ¿no? Entonces 81 divided by 10 times 1 over 9. I reduce and lowest term here is 9 over 10 again. If you want, I encourage you to do verification for the next, but I did that and the answer is okay. So the common ratio is then 9 over 10. So my formula is a sub m is equal to a sub 1 times r raised to the n minus 1. This is exponent. A sub n is equal to 10 times 9 over 10 raised to the n minus 1. You can leave it like that. You can. Oh. If you want, you separate here 9 raised to the n minus 1 divided by 10 raised to the n minus 1 times 10. No? Entonces, in this case, subtraction. Entonces, 9 to the n minus 1 divided by 10 to the n minus 2, no? Because it's subtraction, no? N minus 1, here the exponent is 1. If you want to put it in the bottom, I put it like a negative exponent, entonces double negative, is negative, is negative 2. This is one possibility to express the final answer, no? The people who prefer leave it like that, it's good. And now, I want to find the position 9. Well, it's just plugging in. And in the story, suppose I want to find a sub 9, is 10 times 9 over 10 raised to the 9 minus 1 is 8. Entonces the rest you put in the calculator and you get the big number. It's not important. This is just calculator. Okay? Any question, guy? Well, I changed something now. I changed summation in the geometric sequence. So I need to find the summation. Summation in geometry sequence. So what is the formula? Well, the formula is a little bit weird. Summation is basic summation from K1 to M of the any element gets A1 R n minus 1. And the formula say is A1 parenthesis 1 minus R raised to the n power divided by 1 minus R. This is the formula. R. This is the formula for the summation of the first m elements in one geometry sequence. For example, let me try one example of the summation. Okay, look. This is the number example 2, 3. Example 3. Example 3 now I include summation. Suppose find this. 1/2 plus 1/4 plus 1/8 plus bam plus 1/2 raised to the n power. So find the formula for the summation. Formula. In this case, no number because I don't specification what is m. Actually, our final answer is no number. Is a formula. But okay. After we are computing, for example, for n equal 2, 3, 4, 20, it's the same. Okay, what is the formula? The formula, I'm using this formula, it's a new one. So identification, A1 is 1/2. Look at that, this guy. And the common difference, the common ratio is, well, I have no idea. You divide this divided by this is 1/4 divided by 1/2. 1/4 times, flip it, 2/1 is 1/2. Wow, it's a coincidence again. It is 1/2, 1/2. Okay, you can check in here, it's exactly the same, right? The common ratio is 1/2. Entonces, I use the formula. The formula say S sub m summation, look, it's the same as this. Summation of the m is 1/2. This guy is 1/2. Parentheses 1 minus 1/2 raised to the m power divided by 1 minus 1/2. Okay, 1 minus 1/2 is 1/2. 1/2, 1 minus, well, in this case, I separate 1 raised to the m divided by 1 minus 1/2 is 1/2. It's obvious this cancel. And I know that 1 to the raised to the any number is 1. You know 1 is a magic number. The answer is 1 minus 1 over 2 to the n power. This is the formula for the summation. Let's see, by curiosity, just curiosity, see this formula work or doesn't work in our program. Suppose I want to limit the sequence to 3 elements. N equal 1, 3, 2, and so instead of adding by hand, or let's do it in both ways, you apply that formula. Suppose S to 3. Consider the first 3 elements. It's 1 minus 1 over 2 to the third power. It's 1 minus 1 over 8. And it is 8 over 8 minus 1 over 8 is 7 over 8. Okay, this is the answer using the formula. Stupid, straightforward. It's 1/2 plus 1 over 4 plus 1 over 8. The LCD is obvious 8. We have 4 plus 2 plus 1. Okay, obvious is 7 over 8. That's perfect work. Any question? Okay. Everyone follow me? Are you sleeping? Oh no. Everything okay? Sean? Betancourt? Karen? Okay, still following. Frank? Banks? Okay. Lustin? Following. Okay. Okay. Let's move into one super interesting. Inside this, again, the same situation, the geometric. Suppose this idea is very, very complicated to understand. Look. Suppose you adding 1 plus 1/2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus bam, 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 bam. And this indicates us is infinity. Okay, this summation is equivalent to say, well, by the way, x1 is 1, and the common ratio r is 1/2, no? Because 1/2 divided by 1 is 1/2, 1 over 4 divided by 1/2. Okay, so the formula is a sub m is equal 1, well, a1 r n minus 1, no? A sub m is equal 1, que es invisible. Entonces 1/2 raised to the n minus 1. Basically, the thing I propose you now is find the sum for k equal 1 of the expression que es 1/2 raised to the n minus 1, but this infinity element. Okay, entonces the common sense say that when you're adding infinity number, the answer is infinity. This is the common sense. However, the common sense failed in that case, because sometimes it's infinity, but sometimes no. When the summation, so basically this is this summation que contain infinity element, is called a mathematical series. Entonces, en the series topic, when the summation is infinity, this is called divergent. It's divergent series. It's the adjective. Another way using the action verb is the series diverge. Diverge. Like a verb. Otherwise, this is very, very interesting when the series is equal, no infinity is a number, for example, 2, arbitrary number, I don't know why I select 2. That say that the series converge, is convergent. Using verb is converge. But let me using the intuition to understand. We are in infinity element, yeah, but the problem is that this element is decreasing. It's smaller, 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 smaller. Not always happen when it's smaller, smaller. It's more complicated than this. Okay, when it's smaller, it's always converging. No. But in this case, let me try to understand. This is the first element in geometry interpretation. Okay, you know, it's very, very, in my opinion, very useful in mathematics. Geometric interpretation. Suppose in one line, you are in 1. You are in 1. This segment is 1. The length of this segment is 1. 0, 1. The next digit is 1/2. This is 2, I suppose it's 2. And you add 1/2 is this. This length is 1/2. So we have 1.5, no? Okay. Now, the second element is this. I did the second. The third one is 1/4. And 1/4 is half of the half. It's 1/4. Okay. And the next element is 1/8. Entonces, what do you think? Converge or diverge? Converge or diverge? Because you're adding the number that you're adding is smaller. Is converge or diverge? What do you think? Come on. Converge. Okay, Sean say que es converge. Okay, I agree with Sean 100%. Converge. I have extra question. At what value converge, Sean and Jasmine? At what value converge? Converge means that when you adding infinity element, you get one number. Entonces, my question is, at what value converge? No idea. To infinity. 1 over... No. Sean said get 1 over infinity. This is crazy. 1 over infinity. What? Infinity, remember, infinity is no number. And the operation, the arithmetic operation with the infinity is crazy. It's one symbolic way to indicate us we have a huge number, no? But no. You try to do operation with infinity, you make a mistake, for sure. Entonces, no idea what number converged. It's 2, coño. Look at that. Converge to 2. Because when you increase in 1 over 16, que es the half here, 1 over 32, you know, converge to 2. Entonces, this series converge. ¿A what value converge? Converge to 2. To 2. But I want to prove. This is geometry interpretation, and the geometry interpretation is good to understand the idea, but maybe fail. Let's do it algebraically. So I want to call, look at that. I want to call capital S is the summation for the series But you can apply, for example, a sub m. You suppose que m approaches to infinity. What means that? Okay, this is limited, this is calculus, I know, but don't worry because it's super easy to understand. So you have the formula for the a sub m. Okay, the formula for the a sub m is a1 fraction 1 minus rm 1 minus r. This is the formula, no, for the a sub m. Because I want to manipulate this formula in order to suppose que n is a huge number, because this is equivalent, and the calculus language is using limited. Limited is what is the idea for the what is the difference between algebra and calculus? Bueno, en algebra you plug it in, you evaluate directly. But infinity is impossible to evaluate directly. Any operation using infinity is crazy. I guarantee you. Therefore, approach means, limited means que approach. Y approach es que suppose que n is 2 million, 2 billion is a huge number. That's it. So in order to find compute the limit, I propose you separate this expression into pieces. A1 minus r, so you split the common denominator, and the second one is a1 r sub m 1 minus r. Entonces you apply the limit when n approaches to infinity. We have two expressions, a1 1 minus r minus another limit. Professor, but I don't understand very well the limit. It's also plugging in. A1 Rm over 1 minus R. Entonces, bueno, está bien, es plugging in al professor, I understand. Entonces, this part do not depending of n. Entonces, it's the same, it's a constant, no? Because do not depending of n. This, yes, this depending of n. Look, n is exponent. When exponent increasing forever, it's obvious que r to the infinity maybe it's infinity because it's exponential, right? However, this is good, this is valid when r is a number greater than 1. Look at the exponential that you know very well. Look at your knowledge about exponential function. We have two kinds of exponential. The growth exponential and the decay exponential. What is the difference? The base in this case is greater than 1. In this case, the base is less than 1. Entonces, si you suppose que the common ratio is greater than 1, it's obvious that that part is infinity, and our series is divergent. However, see the common ratio less than 1. When you raise to infinity, this is 0. Look at that here, geometrically. This is x. This is exponential decay. When x approaches to infinity, positive is 0. And this is valid when the r is less than 1. Actually, C is equal 1, diverge. And when this is less than 1, converge. Because it's 0, and that part is not infinity anymore, it's 0 when it's converged. So you need to verification. Okay. What's the idea? You verification first. See, the common ratio in our series is less than, or not exactly less than 1. Look, the most important is absolute value. See, the absolute value is less than 1. Automatically, I know it's otherwise, and the value que converge is this. Wow, and this is the most important formula. I copy big. Capital S is equal A1, 1 minus R. Okay, in the series, remember, you determine the common ratio. See, the common ratio is less than the actual value, because maybe it's negative. I don't care. See, the actual value of common ratio is less than 1. I guarantee that our series converge and also converge to this value. So let's come back by curiosity to the previous example. The previous example, remember, was, let me make it zoom, 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16. And you determine que it's 1. And you determine que the common ratio is 1/2. Oh, but the common ratio is less than 1. Therefore, I agree with you que this converges. Converge to a value, at that value. Let me try to compute that value. A1 is 1. A1 is 1. 1 minus 1/2. Because the common ratio is 1/2. 1 minus 1/2 is 1/2. And flip it out, 2. Converge it to 2. Do you understand very well? Let me summarize the idea for the series. Do you understand very well or no? Converge, diverge, at what value converge? Okay, look at that. Entonces, okay. What is the most important formula? This is the most important formula. So you need to verification number 1. First of all, you verification. If the common ratio, the actual value common ratio is less than 1, directly I can say that our series converge. Converge at what value? S equal A1, 1 minus R. Otherwise, diverge. And diverge means que S is infinity. Okay, maybe positive or negative. Okay, and this is not useful for application. Okay, let's practice example of the series now. Suppose this series determine whether the geometric series converge or diverge at what value. Suppose this series. This example what number? Example 3, no? Example 2. We see example 0. This is the motivation example. Okay, now let's do example 1. Actually, for practice. Plus 4/3 plus A09 plus, and this is infinity. Bam, 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 infinity. Okay, entonces, we're doing several things. Number 1 is express it, this series using the summation notation. Entonces, this is suppose always k equal 1 to infinity. Wow, because it's a series. Entonces, I need to find somehow the a sub m. In this case, is a sub k, because the index variable that we are using is k, but it doesn't matter. What is a totally dummy variable, and you change k, m, I, j, whatever. And you discover a1 is 2. And common ratio, I have no idea. Divided by 2. Entonces 4/3 times 1/2 is 2/3. And I did that. Trust to me, que es common ratio in any possibility. 2/3. Entonces this is 2/3. And the a sub m formula is a sub 1 r, no necessary parentheses, r raised to the n minus 1. Entonces, en our specific example, raised to the n minus 1. When you write here, well, you adaptate, or you change the name of the index variable, or you change the index variable. It's 2 2/3 raised to the k minus 1. Some people know, some people delete that, erase, put m, and you put n here, of course. It's our index. Okay, this problem is equivalent to this problem. Why? I forgot the equal sign. It's equivalent. So you can express this the series like a summation. You declare 1, 2, 3, 4, first element, and when you put that, I suppose that this continue forever using the same pattern. Okay, or more elegant, using the summation notation. No? Okay, ready. And now I go to the series. Okay, my question is convergent or divergent? What do you think? Convergent or divergent? What do you think? Question mark, big question mark. Convergent. Convergent. Because what is the reason? The reason is because the absolute value, so I don't care the sign, in this case positive, but it's okay if it's negative, is less than 1. 2/3, that's less than 1. Therefore convergent. No divergent in that case. Our value, well, the value A1 divided by 1 minus R. A1 is 2, 1 minus 2/3. Entonces 1 minus 2/3 es 1/3, ¿no? 1/3. And flip it is 2/1, 3/1 is 6. The answer is 6. Wow, convert it to 6. Convert it to 6. Convert it to 6. I want to illustrate. The time we have time here. I want to illustrate one fantastic, in my opinion, application for this series. This is not the only one that we have. In calculus 2, we need to see in detail again series. But remember, we are discussing here geometric series. Si it's not geometric series, entonces it's more complicated. So one particular example in calculus 2 is the analysis of the geometry. You identify, oh, it's geometric, okay. Entonces, si es geometric, what is the common ratio? The common ratio is less than 1. Good, convergent. What value of the formula? Apply the formula. A1 divided by 1 minus R. Good. Otherwise, suppose another series is not geometric, so we have more sophisticated tests to determine if it's convergent or divergent. But at least you know the concept. What about is a convergent or divergent? Suppose that we have repeated. It's a one application. Repeated decimal place. Repeated decimal, like that, for example. 0.6 repeated. No, this is equivalent to say 0.6666 and continue forever. I have a question, curiosity, just curiosity. This number is rational or irrational? Big question mark. Big. This number is rational number or irrational number? What do you think? Let me try to Yancy, Betancourt. What about Sean? Sean here. What do you think? Rational or irrational? Do you know the definition for the rational and the definition for the irrational? Or you don't remember that? Okay. Rational is a number we can express it like a fraction. Okay, rational number is a fraction. And A and B both are integer numbers. Irrational, no, we can express like a fraction. Another characteristic is irrational numbers have infinity decimal, but non-repeated. When the number is repeated 66, or not necessarily 66, we see another example que suppose 0.45 bar. What means that? 0.45, 45, 40. Okay, so this number in which is repeated decimal is rational. Is rational. And we can find, you can find the fraction que is identical 100% with the decimal number. Okay, you know, this is no big deal. Okay, you recognize that this is 2/3, yes or no? This is 2/3, yes or no? So 2/3, I put it intentionally, one elementary example, in which when you, for example, in your calculator, you put 2/3, 2 divided by 3, we get 0.666, and the calculator round to the last digit. I put a 7. That's truncate here. The rest of the 6, you condense it like a 1/7, last 7, no? But this is not the idea. The idea is actually 2/3. This is the approximate for the calculator, and this is the exact answer, 2/3. An irrational number, never we can express like a fraction. Okay, there's one fantastic way. Look, let's come back again to this example. 0.6. I want to prove get 2/3. But after I want to solve this. It gets more complicated. This I have no idea. I am totally lost. This is, you can see, okay, this is 6/10 plus 6/100 plus 6/1000 plus that. Because this 0.6 is that part. 0.06 is that part. 0.06. No. 10 is 1000. No, 1, 2, 3 decimal place. Do you understand this, right? This is, you consider like a series from, let me declare n, like an integer to 1, to 1 to infinity. Ooh, infinity here, because we have infinity element, no? Let me try to find by curiosity a sub m here. A sub m, I know that a sub 1 is 6/10. We can simplification a little bit, 3/5. And the common ratio is, you divide, the common ratio is 1/10. Where come from that? You divide 6 divided by 100, for example, divided by 6/10. So 6/100 times 10/6. The 6 is cancelled, and stay alive 10/100, que es 1/10. So my a sub n expression is 3/5, parenthesis 1/10, raised to the n minus 1. This I change decimal like a series, and now summation notation. Okay, my question is, this series converge or diverge? What is the detail that you need to analyze if converge or diverge? What is the detail in which you see they converge? Why, Sean? Sean, let me. What is the reason? The reason is because Sean say converge. I declare like an adjective, no? The series is convergent series. Another way to say the same idea, Because the ratio is less than 1, very well. Because the ratio is less than 1, very well. And what is the value of the convergence? Well, okay, S is equal to A1 divided by 1 minus R. A1 is 3/5 divided by 1 minus 1 over 10. Well, this is 3/5 and this is 9 over 10. Because I consider that 1 is 10 over 10, 10 minus 1 is 9. Finally, I divide 3/5 times, flip it, 10 over 9. Now we got simplification a little bit, divided by 5, 1, divided by 5, 2, divided by 3 is 1, divided by 3 is 2. Oh, the answer is 2/3. Exactly we expect with our experience using the calculator. No, this is no secret. I discovered, nothing I discovered. But it is a way to open the door for analysis more complicated cases. Suppose, okay, I want to analyze 0.45, repeated 45. Wow. Entonces I repeat the question. That number is rational or irrational? Rational or irrational? This number is rational or is irrational? I repeat again the question. Do you understand very well what is the idea for the rational or irrational? Okay, the idea is clear. Look at that. Yes, what means yes? It's rational or, do you understand? Okay, you understand the idea. Rational, when you have infinity decimal, we have no infinity. Suppose we have finite. Suppose 0.4545. It's obviously rational, no? Because it's truncated here. But suppose you have 45, forever, no? 45, forever. This is also rational. The reason is because it's repeated. See, it's completed, for example, 45, 53, 65, 79, 8, non-repeated, this is irrational. And when it's irrational, we can never express like a fraction. This is irrational. Not irrational anymore. And we can find the fraction associated with this is exactly the same. And after we verification with the calculator, no? Why not? Entonces you put 45 divided by 100. In this case, 100 because we have 2 digits. In this case, it was 10 because we have only 1. And the first guy is only 1. Plus 45 over 10,000. Because it's 45, this is 10, this is 100, 1,000, and 10,000 for this. And so, do you see the idea? Bam, 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 bam. And I want to express this idea in summation. Why not? Notation. From n equal 1 to infinity. Who is a sub m? A sub m is a1. Okay, a1 is 45 over 100. We can reduce and lower term. If you want, you can, of course. And the common ratio, the common ratio is, look at that. You divide this guy divided by this guy, F45 over 10,000 divided by 45 over 100. This is 45 over 10,000 times, flip it, 100 divided by 45. 45 is cancelled and cancel out 2 0 and stay alive only 100. And this is the common ratio. Raised to the n minus 1. Entonces the common ratio again is less than 1. It's convergent. Okay, our value convergent and the formula, the famous formula, A1 divided by 1 minus R. A1 is 45 over 100 divided by 1 minus 1 over 100. que es the common ratio. And 1 we can interpret it like 100 divided by 100. And 100 minus 1 is 99 over 100. And here we have 45 over 100. Finally, I copy 45 over 100, flip it that, que es 100, divided by 99, 100 is cancelled, and the answer is 45 over 99. Wow, amazing. This is equivalent to say 0.45, 45, 45, 45 repeated, but I need to verification this on my own calculator. Look, in my own calculator. I need to verification in my own calculator. Yes, I put it in my own calculator. 45 divided by 99. Wow, I can see 45, 45, 0.45, 45, 45, 45, 45. And when the calculator truncate the digit 45, I put a 5, extra 5. Super fantastic. This is one application. There are a lot of applications of this. Everyone understand very well this idea or no? It's confusing, very confusing, eh? Oh no. Understand, Jasmine. Okay. And the rest of the student is okay? Okay, entonces, okay, repeat decimal rational. Yeah. Good conclusion. Sean, when you have a decimal que contain infinity digit, but is repeated in one specific pattern, 2 by 2, 3 by 3, 1 by 1, is rational. You can find one fraction associated with this. See, it's non-repeated, no. It's irrational. And irrational, by definition, is we cannot find the fraction associated with this. Good? Very good or very bad? Okay, curiosity ahora now. Sean, Jasmine, Betancourt, and the rest of the students. Curiosity. What do you think? Hard to follow. Why? What? Hard, Vance? Because I erased the board. No, Vance, what's the problem? I need to understand. Hard to follow me. It's hard to follow me. Vance, what's the problem? Come on. Activate the microphone, please. Come on. You have a question? I don't hear you. I'm sorry, I was trying to take it. Okay. No problem. Sorry. Because I erased too fast. Take a note. What is your method? You take a note in the notebook or you take a picture? A screenshot. And remember, everything is recorded. You can see again and you do. Take a picture. Okay, good. Okay, now, curiosity, pay attention. Let me see if you understand or you don't understand. What do you think about this number? Okay, well, let's using suppose 0.9 repeated equal, I have no idea, question mark. Okay, let's using common sense. And after we are doing by the series, no? To understand. This is equivalent to say 0.9 repeated is 0.9999, bam, infinity 9. What do you think is the answer of this? Using the, okay. Number one. Well, professor, what is the reason you asked this? Number one is, this is a rational number. Therefore, since it's a rational, we can express it like a fraction. And my question is precisely, what is the fraction? My question is, what is the fraction? A over B. Okay. Use intuition first. Intuition. What do you think? Opinion. I need to hear opinions. Okay. You have opinion or no opinion? Or no opinion? So, everyone have no opinion? No idea? Totally lost? Baines, what is the question? The question is, let me repeat again. The question is, compute that number 0.9 repeated. Listen. And 0.9 repeated hay identification que es rational. Y si es rational, we can find a fraction associated with that. The question is, find the fraction A over B. Find that. Got it? Sean say, well, okay, this is 9 over 10 plus 9 over 100 plus 9 over 1,000 plus da. Okay. But I need you try to condense in this infinity fraction and only one, like that. Boom. It's possible or it's impossible? It's possible or it's impossible? Well, it's possible when the series, that series converges. Entonces, identification, A1 es 9 over 10. And the common ratio is this divided by this divided by this is 9 over 100 divided by 9 over 10. 9 over 100 times 10 over 9. Cancel out the 9, it's 1 over 10. And this is expecting it's 1 over 10 when the repeated digit is located in the 10th position. Si es repeated in the suppose previous example 45, 2 decimal place, entonces the common ratio is 1 over 100. But in this case, 1 over 10. Does it converge or no? This infinity sum converges to one number or no? Yes, because the common ratio is less than 1. Does it converge? So we can find that number. Let's do it. What formula we use in that formula? A1 is 9 over 10. And the common ratio is 1 over 10. And also 9 over 10. This is 10 over 10 minus 1 is 9 over 10. Wow, look at that. 9 over 10 equal 1. Make sense in this answer or no? Make sense in this answer que 0.99 repeated 9 is equal 1. It's equal, no es approach, no, it's equal. So I guarantee you que this statement is completely true. Okay? I know. Okay. You accept or you understand? I know a super easy way. I know accept. Okay. So that means you don't understand very well, no? We prove que 0.6 repeated was 2/3, right? And use, if you, for example, divide it by 2, it's 0.3 repeated. Is equal 1/3. Yes or no? Are you familiar with this number, no? If you multiply, this is infinity 3. Look, 0.33. Yeah. If you multiply both sides by 3, this is 0.9 repeated, and 1/3 times is 1. This is one super elementary way to prove this idea. Okay? Okay. Entonces, and the rest of the time que we have, I want to introduce a little bit, not too heavy, the next topic, que is about mathematical induction. mathematical induction. Okay, mathematical induction. The word induction indicates us like we are working like a detective of the police, no? And the detective of the police detecting some tips, several, and find conclusion. This is the idea for the induction. Induction is go to the particular example, to the particular tips, and find general. Go from particular to generalize statement. This is the idea for the induction. I suppose one motivation example. Today only motivation. Motivation example. See, we have time. We're discussing the theoretical part, and now next time we working in the some example. So what is the motivation example? Suppose I want to prove, look, I want to prove that 1 plus 3 plus 5 plus 7, okay, basically is the sum of the odd number. Bang, 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 bang. By the way, what is the a sub n? Si you suppose odd number is 2n minus 1. Es the formula, ¿no? Es the formula because this is like, look like a arithmetic, ¿no? Entonces, suppose que es 2n minus 1. This is a sub n. S equal n squared. I want to prove somehow this. Wow. Entonces, I go to the particular example and generalize to the conclusion. Let me see, for example, so for n equal 1. Well, for n equal 1, we have only the first. This is the first. There's 1. And the left-hand side. This is the left-hand side. And this is the right-hand side. Bueno, 1 equal 1. Because when you plug in 1 here, 1 squared is 1, no? Okay, suppose now n equal 2. For n equal 2, we have in the left-hand side 1 plus 3. In the right-hand side, we have 2 squared. 1 plus 3 is 4, and 2 to the second power is 4. 4 equals 4 is true also. Now, one more. Suppose n equal 3. N equal 3. We have 1 plus 3 plus 5 should be equal 3 squared. And it's A1, 9 equal 9. Wow. To prove mathematically that this is true, we need to do infinity cases, because suppose the worst scenario, okay, doesn't happen in this example, but in another example, yes. Suppose for n equal 500, you get the statement is false. This was true, this was true, this was true. So you need to prove infinity to prove this. This is crazy. It's impossible. I need to find another way to do that. Okay, let me continue. 4 is 1 plus 3 plus 5 plus 7, no? Okay, it's 12, it's 16. Is equal on the right hand side, we have 4 squared, 16. Wow, 16 equals 16 is true. So I believe que es true y I prove. But no. Entonces, now, for doing this strictly, roughly no, strictly true, we using the mathematical induction. Okay, mathematical induction. We come back at the beginning, mathematical induction, and mathematical induction allow us to prove this formula que I put directly in the board for the summation. Okay, we prove in the next class. This is another more complicated. So what is the idea for the mathematical induction? Okay, mathematical induction principle. Mathematical induction principle. Okay, look. The mathematical induction principle have two steps. The first one, okay, the name is base step. Well, base step is you try to evaluate n1, like in this example, you evaluate n equal 1, and it's true. And that's it. I finished the first step. Done. Okay, but what's the problem? Okay, sometimes it's not elementary like that, and suppose that x1 is false. Does I finish? No. Because you try x2 is also false, and you try x3 is true. Suppose in another example, not in this. And so this is my base step. Here I ignore this and this. So not always happen. In the 99% of the case, the first or the base step is at n equal 1. At n equal 1. And we have the second step in the mathematical induction, que is called inductive step. Inductive. That is the most important moment. Okay? So you assume, suppose, que one arbitrary, so suppose we have 1, 2, 3, bam, 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 and we have, for example, 2m. And you pick one arbitrary in the middle here, I call k. K is a number, okay, of course, is greater than 1 or greater than the base step, but it's less than m. So it's intermediate value. You assume a sub k is true. And under these assumptions, you will be able to prove that a sub k imply a sub k plus 1. Okay, this is the next. You assume that in this position is true. However, for another way that I don't want to explain today, the next one is true. Now the conclusion is that a sub k plus 1 is also true. I forgot to say here that this statement to be true. Okay, let me explain it. You assume, number 1, okay, this is true. Okay, this is easy, plugging in, okay, that's it. Now, si you prove somehow that a sub k imply a sub k plus 1 to be true, so this entire statement, by the way, this is the compound statement, this is the conditional, it's true. Therefore, the conclusion is that a sub k plus 1 is true, and this continues forever like the piece of domino. Because look, piece of domino. This is the piece of domino in the position 1. This is the piece of domino in the position 2. Bam, 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 bam. This is the position domino que I select que was true. I enforce it to be true, this case. If you want to prove que the next, que k plus 1, so the connection in between this and this is true, therefore, you can assume que this statement and k plus 1 is true, and this process can fall, continue forever to the infinity. This is the idea behind because it's clear. Suppose que you, I don't know, you assume that x23 is true. Yeah, I can prove mathematically it's true. And you prove that x23 imply x24. This entire statement is true. Therefore, x24 is true. And this process is repeated because now, see, x24 is true. The statement x24 imply x25 is true. Therefore, x25 is true, and this continues forever. This is the fantastic way to prove when you have infinity element. Not necessarily one by one because it's impossible doing a infinity series. Entonces, we stop. Entonces now, surprise, don't worry. Next time I explain again more detail that part, and we are doing several examples. Guys, we almost finished, right? So we have this topic, mathematical induction, and we have one more topic, que es binomial theorem, very important in calculus. And you are ready. So we, what is my plan? My plan is today is 20, no? 20 and 22nd. Okay, next Thursday. We finished the last part, mathematical induction plus binomial theorem, and we spend the next week doing the review. The review is easy. This review is not super complicated, short, because it's the last one, you know, and the material is no big deal. It's acceptable. Now, I sent maybe soon, maybe. Well, I sent Thursday the review packet, no? Maybe Tuesday next week I send the test number 5, and that's it, guys. The final, remember, the final no mandatory. The final is only for the student who need to improve. In some tests, you take the final. The final is crazy because it's cumulative, but it's useful, no? Suppose that in the worst scenario, you fail the final, your grade stays the same. So the thing to compute the overall grade, you find the average. The test 1 on paper and online. See, the average is greater than 90 or equal. Because you have A, no? See, it's greater than 80 or equal. It's B and so on. You know the idea. Okay. Entonces, stop